Okay. So for today's class, we have completed the topic of differentiation in the last class, and we have revised differentiation basically with these two examples, and now we are going to attempt some past repairs from differentiation, and now only integration is left. Okay, so the question is given us question 2021. The function fx is defined by, so they have given you the function fx. It is x square plus k over x. K over x, I can write it down, kx power minus 1 plus 2. For, look at these values. Sometimes this can be useful. X is greater than 0. So this means that you can only put in the values of x which are positive, more than 0. Given that the curve with the function has a stationary point, so they have told us that it has a stationary point when x is 2. This means that if your x is equals to 2, your first derivative will come out as 0 because it is a stationary point. So the value of the derivative should come in multiplies. It multiplies, so 2x power 1. And again the power comes down and multiplies, and power reduces by 1. And this is a constant, so 0 is equals to 0 when x is 2. So this means now 2 times 2 minus k, 2 power minus 2 is equals to 0. And now we can find the value of k. So 4 minus k upon 4 is equals to 0. 4 is equals to k upon 4. And so your k comes out as 16. This would go over there and multiply. सही है, समझ आ रहा है यार?
Yes, sir.
Then they're asking, look, determine the nature of the stationary point. So for this thing, you always have to find the double derivative. So, and then the first derivative we have found, it is this 2x minus x, sorry, minus k we have found, k is 16. 16 x minus 2 is your first derivative, and now you will differentiate it again. So 2x becomes 2, the power comes down and multiplies, so becomes plus 32. X power minus 3, power reduces further. And now we have to find the nature of this stationary point. So when your x was 2, look, so stationary point was when your x is 2. So if x is 2, so the value of the second derivative at this point will be positive. This will be 2 plus 4. I think 32 upon 8 will be 4. So 2 plus 4 is 6, which is positive, and which means definitely that this point is the minimum point. That's it. Then, given that this is the only stationary point of the curve, find the range of f. Given that this is the only stationary point of the curve, find the range of f. We'll find this. Find the range of f. That's a good question. This is the only stationary point. This is the only stationary point. So first of all, find the value of y at this stationary point. So the function is now, the complete function has become x square plus 16 upon x plus 2. So the turning point was 2, x was 2. So f2, the value of y at this point is 4 plus 8 plus 2. 4 plus 8, 12, 12 plus 2 is 14. And this is a minimum point. So this means that the curve is going upwards like this, isn't it? This is the minimum point like this. And this point is the 2 comma 14. And we know that this is the, what is the domain given to us? The domain was given to us that your x is 0. Oh, sorry, greater than 0. X is greater than 0. Look at the question. Look, x is greater than 0. So if it is zero, exactly zero, then your fx will come out as there will be no answer. Look, if your f if you find the value of the function at 0, 0 square plus 16 upon 0. So no solution. This will be asymptote. So this means the function is coming from above like this, and then coming at this turning point, and then because this is the minimum point, the graph will be going up again, isn't it? Some getting it or not? So what is the range, Ryan? What is the range? Ryan, what is the range now?
Greater than like 2.
Greater than 2 is the y value. Sorry, x value.
I'm at
Range is the
14.
y value. Yes, yes, that is your range. So fx is greater than equal to 14. Okay, getting it or not?
Yeah.
Your function, like you can see, if your x is all positive, so your lowest value of y that you're getting is 14, and the value of y is increasing on both sides. So it will always be greater than equal to 14 if your x is greater than 0. That's why this is the answer. Good question. Good question. Okay. So the equation of the curve was given to us: y is equals to 2 plus under root 25 minus x square. Under root, I'm writing this under root as power half because that is better for understanding, for working on it. Then find the coordinates of the point on the curve at which the gradient is 4 upon 3. So definitely this would be any curve. Okay, we don't know how is this curve. It can be anything. Most probably it will be something like this. But I don't know. Okay, we don't know about the curve. But there can be points on this curve where the tangent is 4 upon 3. So this means the gradient of the tangent is always what? The dy by dx. So this means that they have given you the value of the dy by dx 4 upon 3, and they're asking you to find the values of x. Find x when your dy by dx is equal to 4 upon 3. So what you have to do? You will have to find the derivative. This will become 0. 2 is a constant, so 0. Power comes down, multiplies, so plus half. The bracket doesn't change. The power reduces by half further. And the derivative of the inside, which will be minus 2x. 0 minus 2x. And now if you simplify, 2 and this 2 cancel out. So your derivative, for which the value they have given to us, it is 4 upon 3. It is equals to minus x upon 25 minus x square power half. This is your equation that, yeah, that we are forming right now. And now we have to solve the rest, solving for the value of x. Look, they're asking you for the coordinates. So first we'll find the values of x when this is happening, and then we will find the y coordinate as well, because it is the complete the coordinates. They're asking for the coordinates. Coordinates mean the x and the y both. So how would you solve this? How would you solve this? You can square on both sides. So if you square on both sides, because you're going to get rid of the square root, so this would become four hundred is equals to 25 x square. X square will be equal to 400 divided by 25, which will be 16. So your x comes out as plus minus 4. So this means that there are two values of x at which the tangent is the gradient of the tangent is equals to 4 upon 3. And now you want the value of, we will find the value of y as well. So not just the value of x. So if your x is plus 4, so your y comes out as 2 plus under root 25 minus 4 square, which will become 16 minus 25 is 9. Square root of 9 is 3. So 2 plus 9, 2 plus 3 is 5. This is one of the coordinate, 4 comma 5. And the other coordinate will be if your x value is equals to minus 4. So which will be the same, you will get the same answer. Because minus 4 squared and plus 4 squared will be the same thing. So y comes out as 5. So the other coordinate is minus 5 comma minus 4 comma 25. This is the answer. That's why they called coordinates of the point. So there are two coordinates. This is the answer. This is the answer. 5 marks. Okay. The diagram shows a solid cone which has a slant height of 15 and a vertical height of capital H. Show that the volume of the cone is given by this. Okay, first of all, what is the formula for the volume of cone? It is 1 upon 3 pi r square h. And we have the slant height. We don't have the radius. Radius is this one. And this is the capital height that, sorry, this straight height. This is the height we don't have. So h, the height is still h. The radius, we will have to find the value of the radius in terms of this h by using this Pythagoras theorem, the right angle triangle. So 15 square, it is equals to r square plus h square. So r square is equals to 15 square plus h minus h square. So r square is equals to 225 minus h square. So now you can replace this value of r over here. So your v comes out as 1 upon 3 into pi into 225 minus h square into h. And then if you expand the bracket or multiply the h outside inside the bracket, so 225h minus h cube. So this is the one, the same equation. So 2 marks, you got the 2 marks forming the equation. Then they have given you that, given that h can vary, find the value of h for which v has a stationary point. Determine showing all necessary the nature as well. Okay, so we have to find the turning point, we have to find the value of v, the value of h, and we also have to find the nature. So we would have to first of all do the derivative of this equation. V is equals to 1 upon 3 pi 225h minus 1 upon 3 pi h cube. I have expanded the bracket. Now if you differentiate, this will become 1 upon 3 pi into 225 minus the power 3 comes down and multiplies. So 3 upon 3 pi h square. And we have to find the stationary value, so it's equals to 0. Now if you solve this, 225 pi upon 3 minus pi h square is equals to 0. So 225 upon 3 pi is equals to pi h square. Pi and pi cancel out. And so your h comes out as 225 upon 3 square root plus minus. And we know that h, the height cannot be negative, therefore the h value positive we will use. So we have found the value of h, which is positive square root 225 upon 3. This is the value of h for which v has stationary value. And now determine whether this is stationary. This stationary is minimum maximum. So we have found the first derivative. Here is the first derivative. And now you are differentiated again. So d v square upon d h. D square h is equals to, this is the constant. So this would become 0. Then this would become minus 2 pi h. Because 3 and 3, this becomes 1. So the 2 power comes down, 2 pi, and power of h reduces by 1. So 2 pi h. And now you would substitute. If your h is positive under root 225 upon 3, you can see the double derivative value will come out as positive. Regardless of the whatever the value that is, we can see that if we put in a positive value over here, and it will multiply with the negative sign, so the overall sign will be negative. So this means this is a maximum value. Okay, any questions, anyone? An increasing function, they have already defined that it is an increasing function, is defined for x greater than n, where n is a integer. Given that the derivative value, the derivative function is given to you, find the least possible value of n. So the derivative is already given to us. We have to find a least value of n for which x greater than n is increasing. So first of all, they have told us that this should be increasing. So this means the derivative, first derivative will be positive. So this means your x square minus 6x plus 8 should be positive. And how do you solve the quadratic inequality? You first time find the roots. So your roots are x is equals to 2 and 4. X equals to 4. And now with a small sketch, because it is, this one is 4, this one is 2. Because it is more than 0, so you will shade the part which is above. So x is more than 4 and x is less than 2. So which one you can see? This means the value of n is 4. The least value of n is 4. X greater than 4 will always be, the gradient will always be, the dy by dx will always be positive. Okay? Do you get it? Any questions?
No, sir.
This was, you can see the logic is still the same. You have to understand what are they telling you, what information they have given you, and how you have to use that further. They're just rephrasing the thing so complicatedly, but it's actually the same logic. The increasing decreasing function. That's what you're doing the practice for. Understanding the question what they're asking you, and then the rest of it is simple. The dimensions of the cuboid are given x, 2x, and 4x. Show that the surface area and the volume are connected by this relationship. So the volume formula is LBW, right? LBH. So x times 2x times 4x, which will become 8x cube. And the total surface area, it is twice length by breadth plus twice breadth by height plus twice length by height, and then you add them up, right? So if you find this, the total surface area, 2 times length, this, let's suppose this is length, this is breadth, this is height. So length by breadth, 8x square plus 2 breadth by height, 4x multiplied by x, this will be 4x squared plus 2 length by height, 2x multiplied by x, which will be 2x squared. And now if you sum all of it, 16x square plus 8 plus 4, 16x square, 16 plus 8 plus 4, 24 and 4, 28, 28x square. This is the total surface area. And now they're telling you that S is equals to 7v2 upon 3. Let's see. The total surface area we have found it is 28x square. Is this the equal same as 7 times 8x cube power 2 upon 3? So how much will this be? 8 power 2 upon 3. The x is already, I can see it the same. 7 multiplied by 8 power 2 upon 3. Sorry. 7 multiplied by 8 power. Look, 28. So 28x square, it's the same thing. Left hand is equals to right hand. So therefore shown when the volume of the cuboid is 1000, the surface area is increasing at hmm, so volume is 1000, the total surface area is increasing at 2 centimeter square per second. Find the rate of increase of the volume. They're asking you to find dv by dt. Using this, we can find the ds by dt. Sorry, ds by dv. If you differentiate, you will get 7 times 2 upon 3 v power minus 1 upon 3. 14 upon 3 v negative 1 upon 3. And they have given you that v is 1000. So if v is 1000, so the value of the ds by dv, it is equals to 14 upon 3 into 1000 1 upon 3 negative. So 14 upon 3000, 14 upon 10, I think. 30, 30, 30. 7 upon 15. Okay, so they have simplified it as well. 7 upon 15. And now using the rates of change formula, we have ds over dv. It will be equal to ds over dt divided by dv upon dt. Now we have found the value of ds upon dv. ds by dt, this was already given, the 2 divided by, they're asking you to find dv by dt. So this would go over there and multiply, right? And the other part will go over there and divide. So dv by dt, it is equals to 2 upon 7 upon 15, which will come out as 30 upon 7. This is your answer. So yeah, this is your answer. 4.29. समझ आया? Water is poured into a tank at a constant rate of, look, it is volume per second. So dv by dt is given to you 500. The depth of the water in the tank is h. Depth is h. When the depth of water in the tank is h, the volume v is given by, so v is equals to 4 upon 3 25 minus plus h whole square, sorry, whole cube minus 625 double zero upon 3. Okay, this is the formula for the volume they've given it to us. Find the rate at which h is increasing when at the instant when h is 10. So first, if you differentiate this is a question of rates of change. Whenever you have time and two other variables, volume and height and time, so definitely it's rates of change. So first derivative, 4 upon 3 multiplied by 3, 25 plus h power square, and the derivative of the inside will be 1 minus 0. And if value of h is given to us, it is 10. So you can find the value of dv by dh. 3 and 3 cancel out. 4 into 25 plus 10 square. 4 into 35 square. This is the value of dv by dh. And now the formula of the rates of change that you can form right now is dv divided by dh divided by dt divided by dt. So we have this value 4900 dv by dt. It is given to us 500 divided by dh by dt. So this would go over there and multiply, and 4900 will come and divide. 5 upon 49. This is the answer. So yeah,
जी सर।
at another instant, the rate at which h is increasing is 0.075. Find the value of v at this moment, at this instant. Okay. So they have given that to us that dv by dt, it is equals to 500, and they've also now given that dh by dt, it is equals to 0.075. So now using these two and using the formula, we can find the value of dv by dh. So dv by dh it is equals to 500 dv by dt divided by dh by dt, which will be how much? 2000, 20,000 upon 3. And this is equals to the derivative function that we have found. Look. And now we can find the value of h. And then using the value of h, we will find the value of v as well. So now divided by 4, this would become 5,000 upon 3, 25 plus h whole square. Square rooted, you will get two answers. And then minus 25. So the positive answer for h will be considered minus 25 plus under root 5,000 upon 3. This is 15.825 meters. And if we take negative, it is a negative answer. So we won't consider the negative one. This is what we have found. And now we find the value of the v using the original formula. That's what they were asking you. So using this answer, this is your answer. 4 upon 3 into 25 plus answer cube minus 625,000 upon 3. This is your answer. Correct to three significant figures if you round it off. This is the value of the volume. ठीक है? Okay, Ryan. Oh, Sanchi.
जी सर।
Good question. The second part was interesting. And then the third part of this one. The equation of a curve is given to you. Find the derivative. Okay, we will find it. Find the x coordinate of the stationary point in terms of k. You will okay find that. Then given that k is 1.5, 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of. Okay, this is which air? Which air is it? Have they given you the air?
नो एयर नहीं दिया हुआ।
This is something which is very, very few times that is all tested. I'll give you the information. If you have a straight line, and it has a gradient m. So the angle that the straight line makes with the horizontal theta, it is equals to tan inverse of the gradient. This is the logic behind it. Why tan inverse of gradient? Because what is gradient? If I move the tan on the other side, so tan theta, it is equals to gradient is what? Change in y upon change in x. So let's suppose this is the change in x and this is the change in y. So can you see tan is equals to opposite upon adjacent, है ना? Do you see this?
Yes.
Understand?
Yeah.
Rayan? Hmm. This is the logic behind it. So now when they have given you the tan inverse 2, so the theta, they have given you the value of the theta. Theta is equals to tan inverse of 2. So this means the gradient m is equals to tan theta. If I move the tan back on the towards the theta, so this means that your gradient is coming out as 2, which is the value of your dy by dx. So when they have given you the value of dy by dx, this is the gradient of the tangent. And so therefore the gradient of normal will be negative 1 upon 2. So we have the gradient of normal, and what more do we need? We need the point. We need the point. How will you find the point? They have given us that the value of k is 10.05. So you already have the dy by dx value which is equals to 2, and you put in the value of k as well. So you can find the value of x. And when you have x, you can find y as well using original function. So you have the x and the y and the gradient of the normal, you have everything. And then you would use y minus y1 is equals to mx minus x1 to find the equation of the normal. So yeah, I would ask you people to
Yes.
try this again. Okay, you should try this question again. Ryan, you as well. This is a good question.
Okay, sir.
Okay, I'm stopping the recording now. Good, good, good. Do more questions. Bring in questions over here. We'll discuss.